Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Monitoring and Maintenance of ML Systems. Monitoring and maintenance of machine learning systems are crucial components of machine learning operations that ensure the long-term performance, reliability, and accuracy of deployed models. Effective monitoring and maintenance practices not only involve the technical aspects of the models, but also align with business objectives and regulatory requirements. Given the dynamic nature of data and the environment in which ML systems operate, continuous oversight is essential to mitigate risks such as model drift, data inconsistencies, and performance degradation. Monitoring begins with the collection of relevant metrics that signify the health and performance of the ML system. These metrics are typically divided into two categories: operational metrics and performance metrics. Operational metrics include system-level indicators such as CPU and memory usage, latency, and throughput. These metrics ensure that the infrastructure supporting the ML model can handle the computational load and deliver predictions within acceptable timeframes. Performance metrics, on the other hand, focus on the accuracy, precision, recall, and other evaluation criteria of the model itself. These metrics are crucial for assessing whether the model's predictions remain reliable over time. An important aspect of monitoring is the detection of model drift, which occurs when the statistical properties of the input data change over time, leading to a decline in model performance. Model drift can be categorized into two types: concept drift and data drift. Concept drift refers to changes in the underlying relationship between input features and the target variable, while data drift pertains to changes in the distribution of input features. Regularly updating and retraining the model with new data can mitigate these issues, ensuring that the model adapts to new patterns and remains accurate. To effectively monitor an ML system, organizations can leverage various tools and frameworks. For instance, Amazon SageMaker provides built-in capabilities for tracking model performance and alerting users to potential issues. Similarly, open-source tools like Prometheus and Grafana can be integrated to visualize and analyze metrics in real time, enabling prompt detection and resolution of anomalies. The use of such tools facilitates a proactive approach to maintenance, allowing data scientists and engineers to address problems before they escalate. Maintenance of ML systems extends beyond monitoring to include the processes of retraining, versioning, and updating models. Retraining involves periodically re-evaluating the model with new data to ensure its performance remains robust. This process can be automated using pipelines that continuously ingest new data, retrain the model, and deploy the updated version. Versioning ensures that different iterations of the model are tracked and managed, enabling rollback to previous versions if the new model underperforms or introduces errors. Tools like MLflow and DVC support model versioning and experiment tracking, making it easier to manage the lifecycle of ML models. Another critical aspect of maintenance is ensuring data quality and consistency. Poor data quality can significantly impair the performance of ML models, leading to inaccurate predictions and erroneous decisions. Implementing data validation checks and employing techniques such as data imputation, normalization, and augmentation can enhance the quality of the input data. Moreover, establishing a robust data pipeline that automates the collection, cleaning, and pre-processing of data ensures that the model is consistently fed with high-quality inputs. Security and compliance are also paramount in the maintenance of ML systems. As these systems often handle sensitive data, it is essential to implement measures that protect against unauthorized access and data breaches. Encryption of data at rest and in transit, access control mechanisms, and regular security audits are fundamental practices to safeguard data integrity and confidentiality. Additionally, compliance with regulatory standards such as GDPR or HIPAA is crucial, especially for industries like healthcare and finance, where data privacy and security are strictly regulated. The importance of monitoring and maintenance is further highlighted by case studies from various industries. For example, in the financial sector, a leading bank deployed an ML model to detect fraudulent transactions. Initially, the model performed exceptionally well, but over time, its accuracy diminished due to changes in fraud patterns. Continuous monitoring revealed this drift, prompting the bank to retrain the model with recent data, thereby restoring its effectiveness. This instance underscores the necessity of vigilant monitoring and adaptive maintenance to sustain the performance of ML systems in dynamic environments. Similarly, in the healthcare industry, an ML system used for diagnosing medical conditions experienced a decline in accuracy as new types of medical data emerged. By implementing a robust monitoring framework and establishing a retraining schedule, the healthcare provider ensured that the model remained up to date with the latest medical knowledge and patient data. This proactive approach not only improved diagnostic accuracy, but also enhanced patient outcomes, demonstrating the tangible benefits of diligent monitoring and maintenance. The monitoring and maintenance of ML systems are integral to their successful deployment and sustained performance. Through the collection of relevant metrics, detection of model drift, utilization of monitoring tools, and implementation of robust maintenance practices, organizations can ensure that their ML models remain reliable and effective over time. Additionally, addressing data quality, security, and compliance further fortifies the integrity of these systems. Real-world examples from various industries illustrate the critical role of continuous oversight in maintaining the efficacy of ML applications, ultimately contributing to the achievement of business objectives and the delivery of value to stakeholders. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UExcel, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.